F5 DNS class. This is our first class, and in this class we are going to understand what is DNS and how F5 DNS module helpful in terms of resolving the DNS query. So before starting with F5 DNS, I just like to give you a brief intro about F5 product. So F5, F5 is a company which has the product Big IP, and in this Big IP product, they have different module. So you might heard about F5 LTM, F5 ASM, okay, F5 GTM, that is now known as a F5 DNS, okay. So what is the use of DNS? Okay, so let's understand the use of DNS. But before that, I just wanted to talk about the course that we are going to cover here. These are the module which we are going to cover in F5 DNS. We are going to talk about DNS review and deployment, Big IP DNS services. We are going to talk about global server load balancing as well. Data center and server object we are going to talk. We will also talk about DNS and virtual server. And we will also discuss about DNS and DNS pool, wide IP, etc. So these are the main topic that we are going to talk about. Okay. Under these topic, there are sub content as well. All those things we are going to cover in this course. Now, if we talk about DNS, what is a DNS and why DNS is required? So as you know, the DNS is a domain name system, and this is hierarchical and decentralized naming system, which used to resolve domain name into the IP. So as you know that humans are really great to learn the name, not the numbers, okay? And machine works on the numbers, right? So if you just want to access google.com, so behind the google.com there would be IP, or behind the Facebook there would be IP, right? So name we are able to easily remember, but not the IP. So there is a DNS server in the middle which resolve domain name into the IP. That's the use of DNS, right? And if we talk about DNS query, how DNS query works, so basically you would see over here, this is the DNS lookup happen whenever any client want to access any URL, okay? So for that URL, there would be the domain lookup would be happen. When I say domain lookup, that means name into the IP would be going to resolve, right? So you can see here that this is a client which want to access this fixrunner.com. This is the website, okay? So this is the first step where this client would send request to local DNS server. This is local DNS server to know that whether you have any IP for fixrunner.com or not. If this local DNS server has the IP, okay, against this host name, so this local DNS server is going to provide the IP. But in case on the DNS server, if there is no IP, so DNS server redirect that query to root server. Root server basically stands for dot server. So this is the root server. Under the root server, basically we say root server or root DNS. So under the root DNS, there would be top level domain, okay, might be .com, .org, .us, okay. These are nothing but these are the top level domain. TLD, this is stands for TLD. So you know, your DNS resolver would send the query to root server. It would say that I don't know what is the IP of fixrunner.com, but I would give the address of root server. Go there and ask to the root server. The root server would redirect that query to root server would give the reference to top level DNS, which is .com. So root server would send that I don't know fixrunner.com, but I know the address of .com. Okay, you should check with .com. Now query would go to .com, and .com, in .com, there would be DNS register, there would be DNS server registered. So .com would send the IP of authoritative DNS server. Okay, so now query would go to here. This is the authoritative DNS server, which would be containing the IP of fixrunner.com. Now this would be responding with that, yes, this is the IP of fixrunner.com, and now DNS resolver would store that IP into the cache, and then it would send that IP to DNS client. Now wherever that fixrunner.com would be located over the internet, the query would go there. I mean, that would be HTTP request would go there. Okay, so that's how DNS system works. I hope you are already aware, but if you are not aware, that's fine. Basically, we are going to cover this into the F5 DNS in more detail. Any questions so far? Any one of you?
Yeah, I have a question. Like, which part is there is our ISP DNS coming up? This is authoritative or root server? Basically, we are connecting to the ISP.
If ISP, let's say your DNS server, which is your DNS resolver, let's say this is further sending your query to ISP because you have configured DNS IP as a ISP in your DNS resolver, I mean in local DNS server. And if there is anybody else already browse fixrunner.com and that entry already present in ISP cache, okay, ISP DNS cache, and if ISP is replying, okay, it is not coming from the actual system where that zone file exists, so that reply would be known as a non-authoritative resolving. Authoritative means, what is the basic difference between authoritative and non-authoritative? Authoritative means the server which would be actually containing the zone file of a particular domain name, right? So if the reply is coming from that server, that would be authoritative reply. But let's say there is a server which would be storing the cache, okay, cache only. So that if that server is replying, so that would be considered as a non-authoritative. Is that clear?
Yeah, thank you.
Okay.
Hey, can you hear me?
Yeah, I can hear.
Okay, so are we going to dig in deep, do some capture, TCP dump, and validate all these scenarios?
Yes, we will do that.
Thank you.
Okay, so now we will talk about query. That would be coming from here. I would say from client to DNS resolver. Whatever query is running between client to DNS resolver, that query would be known as an iterative query. This is a iterative query. Sorry, not iterative, but this is a recursive query. The query which would be go between DNS client to DNS resolver, that would be considered as a recursive query. And the query which is going between root server, between DNS resolver to root server, top level DNS or authoritative server, that query is known as a iterative query. Okay, so if someone asks what kind of query we have, so we have basically three types of query we have. One is the recursive query, other is iterative query, and the third one is a inverse query. Okay, right now there is no scenario here for inverse query, but later we will understand what is the inverse query. Okay, so again, this is the hierarchy of DNS, and this is decentralized. This is not store on the any central location. This is complete decentralized infrastructure. Okay. Now you might have seen that most of the time you might configure in your system DNS like this 8.8.8.8. On your system, usually you configure this DNS. Do you know what is this DNS? This DNS belongs from Google, and this is not actual DNS server, but this is a DNS forwarder. This is a DNS forwarder. When I say DNS forwarder, that means your query would go over here. Okay. If this DNS would be containing any entry for particular website, then it would look into its cache. Okay. And from cache, this is going to send the response of the query. But let's say there is no entry on the cache, then this DNS server is going to forward the request further to root DNS. Okay.
That's same as a resolver, right?
Yeah, this is a resolver. Yeah. Okay. But I can say that this is a forwarder because this is also forwarding your query. So this is a public DNS forwarder. Okay, which would be having a good cache memory, and also it can forward your request to root DNS. Now, I would go to next slide. Now, there are different type of DNS services that you can choose for your organization. One DNS service you can choose for your organization, that is a hosted DNS service. That means you are not going to install anything in your organization particular to domain name system. You would be purchasing services from third-party provider, maybe 1, 2, 3 domain. Okay, those are the third party, or maybe you are taking the services from any public DNS services, public DNS service provider. Okay, so one of the service you can avail, that is hosted DNS services. When I say hosted DNS services, let's say this is your organization, and now the DNS server is on somewhere on the cloud. Okay, and this is your organization. Okay, here you are not going to install anything, but whenever you just want to make entry of any website, for example, let's say you just want to make entry of NetMinion.net. Against this website, let's say you just want to map the DNS entry. So instead of mapping the DNS entry on your local premises, you haven't deploy any infrastructure on local premises, but you have purchased the services from any third-party provider. As I told you, there is a company 123domain.com. So you have purchased the services from there. They are going to provide you one managed portal. You open the portal there, you put the NetMinion.net and the public IP which you have on the firewall over here. So maybe you have put the public IP, let's say 107.2.3.64. Let's say this is the public IP for NetMinion.net. So that is known as a hosted DNS services. That means you are not installing any infrastructure in your on premises, but you have purchased the services from any third-party DNS service provider, and from there you are just offloading your all the DNS works. Okay, so when you are doing this, this would reduce few things. For example, you don't need to maintain the server. You don't need to think about the resources who would manage the DNS services. Okay, so basically administration offload you can do to the DNS provider, and you can reduce your local bandwidth. When I say local bandwidth, that means reduce your local resources to manage the DNS services. Also, this is going to provide improved DNS reachability. When I say improved DNS reachability, that means basically, these kind of DNS service provider would be deploying multiple DNS server on the back end, and on the front end, they would providing you portal. So if one DNS server would goes down, your service would never goes down. That means you not need to think about HA. Okay, they are providing a reliable infrastructure for high availability. Also, they would provide the protect against different type of DNS attacks. Basically, in DNS, you would see a lot of DDoS attack. Okay, so if you are using any third-party provider, they would deploy those kind of infrastructure which can block any kind of DNS DDoS attack. Okay, and also it is good option for the small organization. So if there is any small organization, they don't want to manage infrastructure, that's a good option for them. But what the disadvantages if you go for hosted DNS services? So disadvantage is you won't have that much control which you have on premises. Okay, basically on premises you have a lot of control. If you want to copy the DNS zone file, yes, you can do copy from on premises. If you want to make any custom entry there, you can just make the custom entry. Okay, so it would be offering you limited control on the DNS portal. Okay, also it is really very hard to customize or extend the services. For example, if you just want to customize the services, you need to talk to your DNS provider, and they would consider if your request is legitimate. Okay, but if request is not legitimate, so they would deny that. And also this is expensive. Okay, because you have to pay the charges there, number of query per second. Okay, so if there is a million of it in per second, so you have to pay for the million of it per second charges. Okay, what could be other type of DNS services? This is the hosted DNS service, which is over the cloud. Next type of DNS services you can choose in-house DNS, which is known as on-premises as well, which would offer you more control over the DNS services, and it's more flexible, and also able to you can change the, you can customize the DNS services as per business requirement, and you have to just pay for software. Okay, and mostly DNS software are free if this is Linux based. So there is a bind server on the Linux which is usually free. Okay, but the problem is if you are going for in-house DNS services, okay, when you just want to maintain your own DNS services, then you require a expensive internal resources. Okay, in terms of when I say expensive internal resources, that means you have to pay for the engineer who is maintaining that, and you have to pay for the infrastructure where these services are hosted. Okay, so you have to purchase this, you have to purchase the server, you have to purchase the operating system, you have to purchase the licenses, etc. Okay, and also you need to maintain that. If there is any vulnerability, you need to patch them. Okay, and you need to watch that there shouldn't be any vulnerabilities on DNS services or DNS server. Okay, so I hope you got the difference between hosted and in-house. Okay, hosted is externally hosted, in-house means internally hosted services. The next type of DNS services you can go for the split, that mostly organization are using. So for their internal use, they are using a local resources, I mean local DNS server, and for any external facing website, they make entry on their hosted DNS server or hosted DNS portal. Okay, so we can go for the split DNS services as well if you want. Okay, any question among these three?
So, so the either way, we will have same hierarchy on the like in the one in house. If you go back a couple of slides,
Yeah.
the root server will be on our side. Is that the one?
Yeah. In any case, we will follow these hierarchy. Okay.
Okay.
In any cases, the hierarchy would be follow in these basis, whether we go for hosted or whether we go for, you know, in-house.
Yeah,
so basically,
so
whatever DNS server we will mention in the address of our client, you know, when you put the IP address, so at that time it would ask the DNS address as well. So your query, DNS query, would go there. Okay.
which part of these will be the one on the cloud?
This one, your DNS resolver.
Resolver. Okay.
Yeah.
So the resolver. So we're talking about the resolver.
Yeah, we are going to talk about resolver. Okay. So when you make, you know, when you purchase external resolver, that means you can go for hosted one, or you can set up your own resolver in on premises. Yes. So we are going to talk about resolver.
Thank you.
So if we are doing an in-house DNS, we need to connect with that to the root server and TLD servers, right?
Yes, basically, yeah, you should have a, you know, internet connection on those DNS server. Okay, so that it can forward the query to root server. Basically, you would see on the DNS file, you would see that when you configure DNS services on these DNS resolver, so you would see that there are many root server IP that would be already hard coded in a DNS file. So you don't need to worry about that, what root server IP you need to configure. Okay, that is already hard coded in the operating system, or maybe the service which you are going to install. So if you are using Linux, so in Linux we have bind services for DNS, and if you are using Windows, so we have Windows DNS services. Yeah.
Okay, thank you.
Now moving to DNS limitation. I mean, we are going to talk about normal DNS that we go for on premises, or we can go for you know, any hosted DNS. So usually there are many limitation of DNS services. A DNS services, basically, I would give you scenario. The first scenario I'm just giving. Let's say I'm just trying to, this is my client, okay? And in this local, this is a local DNS server, local DNS server. And in this local DNS server, I made the entry for NetMinion.net. And against this NetMinion.net, I made the entry of my IP 107.2.3.24. Let's see. Now, whenever this system is going to send a query, what kind of query? DNS query, basically. So when this system would send the DNS query to this local DNS services, it doesn't matter whether NetMinion application or website is up or not. In any case, this local DNS is going to provide the IP that is binded against this domain name. So this system would get the IP 107.2.3.24, and now it would try to reach to that server, which is basically down. This server is basically down. So that is the one of the limitation of the system, that it doesn't care about the application that is assigned to DNS record. Okay, basically this is a kind of record, a record. So that is assigned to DNS record are up or even existed. So you can make, you can make the fake entry over here, and you know, your DNS server would never be going to check that the particular services are up or application are up. So this is the one of the limitation in normal DNS server. But in case of F5, F5 DNS has the capability to monitor the services that is already enter or bind within the F5 DNS. And if the service is down, so your DNS query would never be going there. Okay. Now, the normal DNS services, basically they do the load balancing based on the round robin fashion. So let's say you have a 2 DNS server over here, and you have made the entry over here on primary DNS server. You have made the entry of this and secondary DNS on this. So your query would go here, and after one query, another query would go to another server. So this local DNS server is going in the round robin fashion. Also, there is no concept of stateful application. When I say stateful application, that means, let's say your DNS services was being resolved by this server, and in case of this server is down, okay, so now maybe there are chances that the query which was resolving over here, they got disrupted. Okay, so here no concept of stateful application. Also, if you just want to update them on local DNS server, so if you made the bad entry of the IP addresses, so there is always chances that that is a human error chances. And it can also answer the limited number of query. So you can consider, if you are creating any DNS services on your on-premises, so that DNS server may answer the limited query. It cannot answer a lot of query. Okay, so let's say if your organization is big, let's say Facebook or maybe any other one which is hitting million of hits in a per minute, right? So your normal DNS server cannot answer those query. Okay, and which would make these server vulnerable to DOS attack. So DOS attack, right? What happened in DOS attack? Basically in DOS attack, the attacker would send a lot of fake query. Let's say I'm talking about DOS attack, DOS or DDoS. So let's say there is attacker, a group of attacker in DDoS cases. They are going, and this is the DNS server. So let's say these hacker sends million of DNS query, 1 million DNS query per second to make the server down. Okay, so when the legitimate user come and try to get the DNS services, so what would happen? Your DNS server is not going to respond. So these are some limitation on the normal DNS server, and considering these limitation, F5 works on their DNS services. Okay, and they improve their services. So whatever you are seeing here, the limitation on F5, those limitation has been removed. Any question?
I have a question, but it's not related to what we talked before now.
Mm-hmm.
So we will talk about the DNS security also, right, in this course?
Yes, DNS sec, yes. We are going to
Okay.
talk about it.
No problem. Thank you.
Yeah. Now moving to next. And now we are going to talk about DNS delegation mode. So basically what you can do, you can delegate your DNS services, okay, to different authoritative DNS server, so that DNS server can answer the query. So let's say you have, let's say this is your primary DNS server in your organization. This is client. And let's say this is primary DNS server or LDNS, local DNS server or resolver. Let's say this resolver is down due to any reason. Let's say down due to maintenance or down due to power failure or anything. So you can define the delegation. Okay, so when you define the delegation role to any other server, so this server further is going to resolve the query that would be sent over here. So now that query would be resolved by the another DNS server, which is authoritative DNS server, and that is a delegated DNS services. Now, moving to next. Now we are going to talk about F5 big IP DNS services. So in your F5 offers multiple DNS services, and these are the main services. F5 offers GSLB, that is global server load balancing. Dns Security it offers. Dns Express it offers. Dns 624 it offers, and Dns iRule services it offers. Okay, we are going to talk about all these services one by one. So let's understand GSLB first. That is a global server load balancing. So as by its name, this would be this services make the application available across the multiple data center or multiple zone. So I can tell in this way. Let's say our company, which is NetMinion, .NET. This NetMinion.NET application, which is web application, is running on the multiple data center. So we have one data center in, let's say, in Europe, maybe in UK. Another data center we have in, let's say, in US. And next data center we have in India. So we have 3 data center, and this NetMinion application is running on each data center. Now we have F5 DNS over here. This is F5 DNS. And this F5 DNS is monitoring all the data center, and the application which is hosted on these data center. So it is monitoring NetMinion, which is hosted over here as well. This is monitoring NetMinion, which is hosted here as well. And this as well, NetMinion is hosted here as well. Now, when user are requesting to get the IP address netminion.net, so maybe user are requesting from different zone. So maybe user in EMEA, we have user sets, which may be in EMEA, which may be in NAM, North America, or maybe we have user from APAC, Asia Pacific region. So when any EMEA user is requesting for what is the IP of netminion.net, the query would go over here, and this F5 would provide topology based load balancing. When I said topology based load balancing, so in that case it would consider the region. Okay, that query is coming from where? The query is coming from EMEA. So this query would go to UK data center, right? So the query would go here on UK data center. When query is coming from NAM, the query would go to NAM data center. When query is coming from Asia Pacific, maybe Singapore or somewhere, the query would go to nearest data center. So F5 is intelligent enough to distribute the services, to distribute the DNS query across the region. And in case any region is not available, let's say India region got failed. So this F5 would be able to know using iHealth. There is a iHealth feature that the health of this data center is down. So the query which would be coming from here for the APAC, now that query may be going to redirect it to next nearest data center. Okay, and next nearest data center is UK based. Okay, so GSLB, this feature would provide F5 a functionality where F5 can distribute the query across the different region, and also it can monitor the health of the connected data center. Is that clear?
Yeah. So question here.
Yeah.
So where is the GTM or GSLB on that flow that you mentioned, root and resolver and the authority or TDL?
It would be in front of resolver. So your resolver would be primary and F5 would be secondary. So I can say, if I go in that flow, over here, so this resolver would be, this would be primary. This is a primary. And when you deploy F5 DNS over here, F5 DNS services. So this, a copy of this would be working as a secondary. Okay. And all the sync between primary and secondary would happen. Now your query, instead of going on the local resolver, the query would go here on F5. And whenever you make the changes on primary, that is going to sync to secondary. That means F5 is knowing that. And now all the requests would be resolved by F5 itself, not resolved by this DNS resolver.
I see.
Yeah.
Client, the DNS client has its own DNS server. So how you will make that happen that it will not go to its DNS
basically we have to change the DNS server on the DNS client side. We have to change, and we have to define that, not the DNS resolver, but we have to define the DNS server IP as a F5 IP, F5
but
listener IP.
You are running Amazon.com, and you cannot go to each and every client, like change my DNS resolver is this particular IP. So
no,
they will
I would say, yeah, I got your query. Basically, you are talking about the public DNS services, right? So I got your query.
Yeah.
So basically what happened in a public DNS services, whatever the listener you are going to create, okay? So maybe the listener which you are going to create on the F5, this is F5. On F5, you are going to create a listener against a particular IP. So let's say you just want to create a listener for a fixrunner.com. So for fixrunner.com on F5, you are going to define IP 100.0.0.7. So what would happen here? You, instead of authoritative DNS server right here, this is not an authoritative DNS server in case of public domain, right? The public, in case of public domain, your F5 would be authoritative DNS server. So your root server, or sorry, your top level DNS server is going to give the IP of the listener that is made the entry on the F5. You got my point?
So what is the difference between when you said DNS resolver will be a primary, F5 will be primary and secondary, and now F5 stands where?
You could have a two types of DNS server. One is the internal facing and other is the external facing, right?
Okay.
So I would give the example of, let's say.
So when you said in primary, secondary, you were meaning like internal, primary, secondary.
Yes, you can define internal, primary, secondary, or I can draw another diagram. Basically, in this, this is going to make a little confused. So let me just talk about that. Okay, I'm drawing over here. So let's consider this is a different organization. This is the user, and that is on different organization, and they just want to browse NetMinion.net. This NetMinion.net would have some entry somewhere. Okay. So obviously for this NetMinion.net, there would be one DNS server where entry would made. So let's say this was the DNS server for NetMinion.net where entry has been made. So when this server is going to reply for the query, this server would be considered as the authoritative DNS server, right? So let's say this is primary DNS server, and this is also authoritative. Now this is a client, and this client is somewhere else. Okay. Now this client want to browse NetMinion.net. So what my company has done, NetMinion has done, they also have put F5 there. And on the back end of F5, they had put this primary server, right? Now, instead of making the entry on here, okay, we have, this is working as a primary and this is working as a secondary. So on when we have registered our DNS services somewhere, we have put the IP of F5 listener. So against this NetMinion.net, who is going to resolve? I have put the IP of my listener, and my listener IP, let's say 100.0.0.7. Let's say this is the IP of my listener. Now this person want to make the query. This made the query for what? For NetMinion.net. Obviously, this query go where? To its local DNS. Wherever this user exists, this would go on the local DNS, LDNS. Where this LDNS is going to forward that query? To root domain. Root domain is going to forward that query where? To TLD, top level domain, .net. TLD, that's a top level domain, .net. And in this .net, instead giving the IP, the address of primary DNS server, it would giving the IP of my listener. Okay, that it would say that I don't know NetMinion.net, but I know someone who can tell the IP of NetMinion.net. So it would give the address of my listener that this can give the IP of NetMinion.net. And in this F5, there would be already entry for NetMinion.net, and it would provide the IP to this system. And the reply which would be coming from F5, that would be authoritative reply. This would be authoritative reply. Okay, so you got the point. That means when you have external DNS, so instead of exposing your primary DNS server over the internet, you are exposing the IP of your F5 listener. Is that clear?
Okay, and you can do that.
Yes, you can do that.
Okay. And how you do that?
Basically, when you are going to make any entry of your DNS services, on that cases, you are going to give that. I mean, when you are defining the name server, right? Usually you would be defining the name server for your website. Okay, so in the name server IP, you can give the IP of your F5 listener. Name server means the server which would be resolving the name.
Okay.
Yeah.
So that name server becomes the authoritative DNS server.
Yes, right.
And there are certain, then it will not come to the primary.
Yeah, query would not come to primary. That's why when you are putting the F5 DNS, this is going to provide the security, because F5 can handle the query in much better way because it has a dedicated hardware, right? But not your server. Okay, that's why company is putting F5 in front as a
Is there any
secondary
other
server.
way to do it?
Sorry, is there any
Other way we do it?
for protecting your DNS server?
No, like forwarding the DNS query instead of like adding name server.
Mm-hmm.
It's like adding CNAME.
No, that is a different entry. CNAME we are not going to add. We are going to add that who is your DNS server over here. 100.0.0.7 is a DNS server. Okay. Maybe your primary DNS server has some different IP.
Yeah.
So we are not exposing primary DNS server over the internet, but we are exposing the IP of your F5 listener. Okay, which would be listening the DNS query.
So the 100.0.0.7 is the DNS, not the backend IP.
No, this is not a backend IP.
Okay, so this is the DNS. Okay, so this
Yes.
is the FAQDN. Is that the FAQDN or the FAQDN is the NetMinion?
NetMinion, NetMinion IP should be different. Something else. As I can say that NetMinion IP could be 100.2.3.24. This would be NetMinion IP. Against this IP, there would be entry on the primary DNS server. Okay. And this entry would be synced with the secondary. Okay. So whenever the query come from here, from top level domain to here, okay. So this is going to listen the request which is coming on the port number 53. So this is nothing but this is a listener, as I told earlier. So this is listening the query. This is listening the DNS query. And after listening the query, this is going to do the response. So when this is going to respond, so on respond, this is going to provide this IP 100.2.3.24. This IP is only to listen DNS query.
Okay, so when I do NS lookup from the client, I should see the .24.
Yes, .24 you would say, right?
Okay.
And server you have to define 100.0.0.7 if you want to define, else it would already do the DNS resolve on 100.2.3.24.
And that .7 should be advertised to the internet in order to.
Right.
Okay, got it.
The name server would be, this would be the name server. This would be the name server. So this entry would made on the portal where this NetMinion.net is running. So on that portal, we have to tell that what is your name server. So this is the name server.
I see.
Yeah. Okay. Now moving to next. The next service of F5 DNS is a DNS security. So what is the DNS security? Basically, there are chances that man in the middle attack could happen when the reply coming from the DNS server. So I would give the example over here. So let's say this is a user who made the query, and let's say this DNS local DNS server LDNS is, sorry, this is not on premises. This may be third party hosted. This DNS server is DNS server, which is resolver, is third party hosted. Now it asks the IP of facebook.com. Here is facebook.com. And let's say facebook.com got 2.3.5.1. This is IP of facebook.com. Now this hosted DNS server knows the IP of facebook.com because on this hosted DNS server, there is already entry against the facebook.com. So there is already a record. That means the entry of this host name and its IP. Okay. Now this is going to make the query. It send the query, the DNS query. And this query is going over the internet. What if the reply is coming from this DNS server and in between someone modified the packet? Someone did the modification of the packet, and instead of putting the right IP, this IP, which this DNS server was sending the for facebook.com, for this facebook.com, the IP is 2.53.5.1. Let's say there is an attacker who fetched the packet and now modified the IP, any fake IP. It put its own IP, maybe 100.7.2.3 against this IP. Now where it is going to reach? Instead of going the Facebook, this is going to reach redirected on the malicious page, right? So considering this, there is a DNS sec feature got offered, okay, which is basically introduced by the ITEF force, okay, that is Internet Security Force. So they release they work on the DNS security, and they said that whenever the reply is coming, make sure with the reply there should be digital signature attached. Okay, so when the reply is coming, this reply is not coming with the simple way. This is coming with the digital signature attached. And you know what is the use of digital signature? A digital signature would be used to verify the reply is coming from the authoritative source or not. So if the digital signature of this server is matching, okay, then this is going to accept. And if not matching, this would know that now the query has been modified. So F5 does offer DNS security. In F5, you can configure the DNS security. DNS sec you can configure, where all the responses which would come from the F5 would be trusted, and it would prevent the DNS cache poisoning or DNS modification. Right? Now I'm moving to next one. The next feature, which is DNS Express. Yes, so this is one of the great feature of F5 DNS. As I told you, DNS Express, this is nothing but this is a enhanced DNS query. Okay, so your F5 is providing the feature which is known as a DNS Express, and this DNS Express can resolve the million of query in per second and it can handle the DOS or DDoS attack as well. Okay, so as I told you, let's say in your organization, let's say this is your organization, and you have configured DNS server over here. Okay, now if people from the outside sending the DNS query to this server, okay, so when the query is number of queries in limited, so limited query can be handled very carefully by this DNS server. But let's say query are lot of query, there are millions of queries coming, so this DNS server would crash. So what the solution we have, we can put F5 DNS over here in front of that. As I told you earlier, this is F5 DNS, and in this F5 DNS we can configure the feature which is known as a DNS Express. DNS Express, what this DNS Express does, basically this DNS Express would do the zone transfer. Okay, so basically what it would do, it would, the primary zone file would exist over here. You know zone file, right? There would be entry of the all the domain name, etc. So primary zone file would be here, and the copy of that zone file would be stored by this F5 DNS. Now if the query is coming from outside, all the queries would be resolved by F5 DNS itself. The query would never go to your primary DNS server, and in that case your primary DNS server would be always protected. Okay, whenever you just want to make new entry, so where you would make the new entry, let's say NetMinion.org website you just want to make as a new entry, so you would make that entry on the primary, and that file would sync with the F5 DNS. Okay, so for netminion.org as well, your F5 is going to respond. So this DNS Express feature, making your F5 DNS high speed, high response and authoritative DNS server, and it would use a zone transfer feature using which it can host the same copy of the file which is on primary, okay, and it can resolve the domain name. Clear? Or any question?
Yeah, it stores the DNS from the backend, from the primary server, or it always makes a query.
So there is a AXFR feature using which you can transfer the file, a DNS file from primary to secondary. That means you can copy the same number of records to F5 DNS.
But there are frequent updates happening on primary, no?
Yes, if the frequent update happening, in that case as well, your secondary, I mean, you can set that what would be the sync time would happen. Okay, so sync time you can configure 5 minutes, 10 minutes as per your requirement, you can configure. So between primary to secondary, what would be the normal sync time?
And well, in that case, it's not available. So it makes DNS entry is not on F5, then it makes a query.
Yes, if the DNS entry is not a F5, so definitely F5 has the capability to send that query over to root DNS as well. But here we are, I mean, in this scenario, what we are going to use? We are going to use this F5 to resolve hosted website, okay, that is hosted in our organization. So definitely there would be entry.
Okay, got it.
Yeah. I can give you one scenario in this way, okay, however you got it. Let's say in my here, we have NetMinion.net, but not NetMinion.com. We don't have entry for NetMinion.com in my organization. Now what happened? TLD, which is top level domain, TLD gave the response to these user query to this F5 listener. So on F5 we have listener maybe 100.0.1.2. This is a listener which is listening on port number 53. Now this user would make the query for netminion.com. So my F5 directly is going to tell that we don't have entry of netminion.com. Okay, that is a simple authoritative reply that netminion.com does not exist, but netminion.net exists. So when these users are going to make the entry query for netminion.net, F5 is going to tell, yes, this is the IP for netminion.net. But when this is going to tell query for netminion.com, so F5 directly going to tell that we don't have entry for netminion.com. Okay. Okay, now moving to next. The next feature is DNS 624. So let's say you just want to upgrade your infrastructure in IP version 6, but your backend server is still running on IP version 4. So you can use F5. On front end, it would be listening on IP version 6. And on the back end, it would be translating that request on the IP version 4. And also, you can use F5 DNS and you can customize it using iRule. So you know iRule feature, right? iRule is a simple script-based services which you can use by creating the script. You can manipulate the traffic. So when I say manipulate the traffic, so you can manipulate the request, response, etc. wherever you need it. So yes, DNS supports iRule as well. So if some of the feature is not present and you just want to customize those features, and if you are good in iRule, you can create iRule.
So for that 64, DNS 64.
How to create the iRule? Is there any references is there to show to here?
Yeah, basically you can take the F5 reference as well. I would share when we have in next class. So I would share the reference for the I rule.
Hey,
Yeah,
so
go ahead.
for DNS 64, so in this case, the listener will be IPv6
Right.
and the backend will be 4. Is it
Right.
vice versa as well, like 4 to 6 as well?
Yes, it is also possible. 46 also possible.
Okay, thank you.
Are we going to see all of these in detail?
Yes, definitely. We are going to see all of these in detail.
Just one more question. These info blocks, they are doing the same thing?
Sorry, in?
Inflow box, the vendor.
No,
the
I don't
DNS
have. I don't have idea of Flowbox.
Oh, no.
Sorry, but I do have idea of the Citrix. So they are doing a similar kind of stuff. Okay, so Citrix GSLV feature is there. So yes, they are doing. I mean, most of the technology are doing same thing. There may be featured something different, but yes,
Okay.
doing same thing.
No, I have seen this info block somewhere for the DNS security or something. That's why I was just asking.
Yes, yes, they would be supporting these features. Any of the vendor would be including those features.
No problem.
Yeah.
Thank you.
This is the decision flow. So what I'm just going to do, I'm stopping over here. The decision flow, I would let you know that when we have, I mean, how the DNS query would happen and how F5 is going to resolve the IP and what is the preferences. So this is the decision flow. So this decision flow we are going to cover in next classes. Okay. The reason is first you get the access of your lab. This is our lab, right? So get access of this lab so that we can do some configuration. Okay, so you would see that we have two sites, one site in London and other site in New York, and we have these server on the back end. So this server is a DNS server. Okay, and these DNS server would able to edit on the LTM boxes or directly on the GTM boxes. When I say GTM, the DNS boxes. And we can generate the query from here, from workstation to the listener, which would be on the GTM. And that would be sending the query to back to the Linux server, or maybe this listener can resolve the query itself, okay, for a particular IP. So what I would say, suggest get the access of this lab and let me know by tomorrow. Tomorrow we are going to do a configuration this server. First we will do the DNS configuration on this server, and later we are going to configure the listener etc over here, right? So I'm just stopping here today, and let's meet tomorrow.
Every day, 1 hour every day?
No, it would be 2 hours. So this is
Okay.
our first class. So here I'm just going to take 1 hour, but from next classes we have 2 hours.
It's going to daily basis or Saturday, Sunday only?
Saturday, Sunday.
So how we can get that
Slide.
access, the slide or the access to the lab? Should we get some
So
email?
yeah, no, you can talk to your coordinator. Okay, you might have their WhatsApp address. I mean number, or maybe email. So you can talk to your coordinator. They would assign the lab to you. Okay, and can go forward.
Okay, so a question about, do we expect at the end of this course, like we can get the, are we ready for GTM exam? Or
yes, you can go for GTM exam after this. Okay, because we are covering everything related to GTM. So whether that is GSLV, whether that is DNS, whether that is DNS, everything would be covered there.
I see. Okay.
Yeah.
Thank you.
No problem.